In exam style question 3, we have the diagram. In the diagram, A, B, C, and D lie on the circle, and the center of the circle is O. EA is tangent to the circle at A. Angle EAB is 61 degree, and angle BAC, this angle is 55 degree. So first we have to find angle BAO. To find angle BAO is this angle. Notice that OA is the radius and EA is tangent. So first we will decide that it's the radius and the tangent angle property of the circle we will use. Tangent is perpendicular to radius. If tangent is perpendicular to radius, then it means the whole angle, including this 61 and this angle theta, will be 90 degrees. So we will interpret and compute that 61 plus theta is the angle between the radius OA and the tangent EA, and they are perpendicular. So it'll be equal to 90 degrees. This way we can find theta, which is 90 minus 61, which will be 29 degree. And is theta the required angle, BAO? Yes. So it's the angle BAO, 29 degree. In part B, we have to find angle AOC. Angle AOC is this angle. And as we know that OC and OA are the radii of the circle. So it means the radii are equal. It means the triangle AOC is the isosceles triangle. If we know base angle, one of the base angle, other would be same. And this way we can find out the angle at O by using the triangle angle properties. So we have to decide that in the part B, actually, we will consider triangle AOC, and AOC is isosceles triangle, is isosceles. It's an isosceles triangle. So what we have to do, we have to find one of the base angle. If we find one of the base angle, let's say the base angle would be angle A here, which is easy to find because this whole angle is 55 and we know that this is 29 degree. So angle at A in the triangle AOC is gonna be 55 minus 29 degree, which is 26 degree. Similarly, the angle at C would also be 26 degree. So angle at C in the triangle would also be 26 because these are the base angles of the triangle AOC. And henceforth, we can find the angle at O. We will finally compute and conclude that angle at O, angle at A plus angle at C in the triangle sum up to 180 degree. Henceforth, the angle at O will be, therefore, we just have to subtract the sum of these angles from 180. So it's going to be 26 plus 26 going to be 52. So 180 minus 52 degree, it's going to be 128 degree. So angle O is actually the required angle AOC, which is 128 degree. In the next part, we have to find the angle ABC. Angle ABC is this angle at B in the triangle ABC. Or you can consider that because AC is an arc, if we say AC is an arc that subtends the angle at the center and also on the circle at point B. So we will use the property that an arc that subtends the angle at the center is twice of that angle which it will subtend anywhere on the circle. Okay, so now let's use that property. Angle ABC is the angle on the circle. So it will be half of the angle AOC. And henceforth, angle AOC is 128. So it's half of 128 degree. And it's going to be 64 degree. Find the angle CDA. So CDA is this angle at the vertex D. Angle at point D, CDA. To find the angle CDA, we will consider ABCD a quadrilateral, and all the points lie on the circle for this quadrilateral. This is a cyclic quadrilateral, and we do know that opposite angles in the cyclic quadrilateral, which are angle at B and angle at D, will sum up to 180 degree. So we will consider or decide that here is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. And if it's a cyclic quadrilateral, the angle ABC plus angle ADC will sum up to, or angle CDA will sum up to 180 degree. Angle ABC plus angle CDA will be equal to 180 degree. This way we can find angle CDA, taking the ABC angle to the other side, I mean subtracting it from 180 degree, and angle ABC was 64. So 180 degree minus 64 is gonna be 116 degree.